Like it or not, believe it or not, climate and environmental change promises to affect all 7 billion of us in a whole range of different ways through an intricate web of interacting processes. I'm Neil Edwards from the Open University, and I study the dynamics of climate and Earth system processes, and I'm coordinating a European project that's looking at the impact of climate change on economies and society. The only effective way to avoid the worst of climate damage is a rapid and drastic reduction of fossil fuel emissions. We can switch to biofuels to reduce fossil fuel usage, but if biofuels replace crops, they may not be enough to eat, particularly if agricultural yields are affected by climate change. How do we know which is best in the long run, growing food or growing fuel? Massively increasing irrigation, on the other hand, could allow us to grow much more food, but that might mean there is not enough water for drinking or for thirsty industrial processes. Climate change is not just about average global warming. It'll have different impacts in different regions and affect our lives in a multitude of different ways by affecting different types of human activities and natural systems. Melting ice sheets and sea ice may seem remote to some of us, but they lead to sea level rise, which is a very real danger for millions. Impacts on forests and sensitive ecosystems will affect biodiversity and affect agricultural production, changing which crops will grow and which won't. Changes in the hydrological cycle will see some places receiving increased precipitation and others reduced precipitation, changing patterns of flooding and storm damage. Energy systems will also change, affecting how we build, heat, cool, and power our houses and industries. These processes are highly uncertain, but they're not completely unpredictable. Scientists and economists use a whole array of sophisticated computer models to predict future change. Models of terrestrial ecosystems, the climate system, the global economy, and even the game theory of international negotiations. But there are two problems. Firstly, all these different computer models are written in different computer programming languages and have trouble exchanging information. Secondly, many of these models run very slowly, taking weeks to suggest just one possible future. But because we don't have perfect knowledge and understanding, we really need to investigate many thousands of different possible futures. Policymakers badly need solutions to these problems to ensure that rules and regulations designed to protect against one aspect of climate change don't create more problems with respect to another. What they need are robust policies to ensure that food, fuel and water are sufficient for us all. ERMITAGE is a European research project that aims to solve some of these problems. ERMITAGE stands for Enhancing Robustness and Model Integration for the Assessment of Global Environmental Change, and it brings together 7 research and teaching institutions from around Europe and around 30 people using novel software approaches, cutting-edge environmental modelling tools, statistics, economics, and even game theory of international negotiations. One of the novel techniques we're using is to use statistical methods to create much faster versions of the computer models. Climate models work by dividing the atmosphere into thousands or millions of boxes and solving the same set of fundamental budget equations in every box. But stupid computers don't realise that the climate in one box will be almost exactly the same as the climate in the next box. They'll do an enormous amount of work to calculate the future climate in one place, then they'll repeat almost exactly the same work in the next box to find almost exactly the same future climate. They have to do that because they wouldn't be reliable if they didn't. But the human brain works in quite a different way. We use layers of extra information to see similarities and patterns. Now, we can't rely on those patterns to replace rigorous calculation, but we can add that information on top of the simulations from climate models. And adding those sources of information together is exactly the domain of statistics and statisticians. Policymakers around the world have to make tough decisions on CO2 emissions targets, energy, food, trade, water and economic policies, all of which interact with climate change in complicated ways. The purpose of ERMITAGE is to provide policy and decision makers with better modelling tools so they can take better informed decisions to protect the other 7 billion of us from the worst impacts of climate change.